So welcome once again students, welcome to our TEJAS series. Please do like and share the video and subscribe the channel. Okay, so that's the question for today. I hope you all would have tried your best to solve it. So but since you got this question under our topic of complex numbers, first question was of complex numbers, so of course nothing is said about these two like parts of the question, whether you have to solve it using trigonometry or complex number. But since I'm taking up questions of complex number these days, as you would have observed, the complex number or integration, that's what I'm taking up. So the purpose of giving this question or discussing this question or sharing this question with you all was to look at this, how to solve it with the help of complex number. Okay, so that's the purpose here. So let's try, let's start. So first one is, we have to find the value of pi. Pi stands for product, symbol of product, like sigma is for summation. So k goes from 1 to 5 and it is sine of k pi. Sine of k pi by 11. Okay. Now in such type of question, I will say this hold the key. So I will start with 11th roots of unity concept. 11th roots of unity. Okay. So consider the equation. Consider equation z is for 11 is equal to 1. So its roots are 1, alpha square dot 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 alpha raised power 10. Okay, in general, where we know that alpha raised to the power r is sine of, cos of 2r pi by 11 plus iota times sine of 2r pi by 11. Okay, we all know this. Okay, we have already used the roots of unity in few questions earlier also. We know that. Moreover, we also know that the first complex root of unity and the last complex root of unity, they are conjugate of each other. So alpha and alpha raised power 10 are conjugate of each other. Similarly, alpha square and alpha raised power 9 are conjugate of each other. Alpha cube and alpha raised power 8 are conjugate of each other, and likewise we can pair them up. Okay. Now, since we know roots of this equation, we all know that we can write it in factor form. So minus 1 is equal to z minus 1 into z minus alpha. Z minus alpha raised to the power 10. Deliberately I am writing the last factor along with it. There is a reason, you all will understood it. Z minus alpha square and then its conjugate pair along with that, minus alpha raised power 9 and so on and so on. Okay. So now bring it this side. So z raised power 11 minus 1 upon z minus 1. So that's one thing. Okay. Now forget about it. Now let's write it. Okay. So this is z minus alpha into z minus alpha bar. Fair enough. Okay. So now what does that mean? Similarly, this is z minus maybe beta and z minus beta bar. Okay, I am considering alpha square to be some denoting it with beta. Okay, so first let us do it for this one. What I want to show you all. So just multiply it. So how many such pair will be there? That's the first question. Of course, there are like 11 roots, 11 factors. I took the first one, z minus 1, to the denominator of LHS. We are left with 10 factors, so we can pair them up in 5 pairs. Okay, which 5 pair? The conjugate pair. Okay, so we have 5 such conjugate pair. So z minus alpha and its conjugate z minus alpha bar. Similarly z minus alpha square and its conjugate z minus alpha square bar, or alpha raised power 9, so on and so on. So we will be having 5 such pair. So let's take up the first one. So multiply it. So what do we get? Z square minus z times alpha plus alpha bar. Multiply it plus alpha bar. Okay, so it's z square minus. If you add a complex number and its conjugate, you get it's 2 times the real part. Real part of alpha into z, and z into z bar is mod z whole square, and it's a root of unity. So mod of alpha, modulus of alpha is 1. So it's 1 here. So that's 1. Okay, now I will say put z. Actually we have to either put z is equal to 1 or z is equal to minus 1. That's one thing. By substituting z is equal to 1, we will get the product of one type of series like sine series, or by putting the other one we will get the other type of series. That we have to decide, and that we can decide once we try to put the value. So I will say, okay, put z is equal to 1 both the side. So what will happen this side? So if you put z is equal to 1 on this side, you will get 0 by 0 form. But if you wish, you can look at this term as the formula for series of a GP, r raised to the power n minus 1 upon r minus 1, and a is also 1. So if I write 1 here, so a into r raised to the power n minus 1 upon r minus 1. So what is it? It represents the sum of 11 terms of a GP whose common ratio is z, first term is 1. Okay, so we can remove that 0 by 0 part. How? So I will write it as 1 plus z square. Z is for 10, isn't that? First term is 1, their total number of terms are 11 with common ratio z. So that's the series we get. So I am just writing it here again, z square minus 2 times real part of alpha times z, and this is plus 1. Similarly, enter bracket, enter bracket, enter bracket, 5 such brackets are there. Okay, now put z is equal to 1, so you have 11 here. Fair enough? Put z is equal to 1, so 2 minus 2 times of real part of alpha. Now what was alpha? Alpha will be, so as I said, the roots of unity, alpha raised to power r, so alpha is nothing but cos of 2 pi by 11 plus iota sine 2 pi by 11, isn't that bacho? So real part is cos 2 pi by 11, so just take the value here, 2 cos 2 pi by 11, that's the first bracket. Similarly, second, third, fourth, and fifth bracket is there. So we have 11 is equal to, take 2 common, we have 1 minus cos 2 theta, theta is pi by 11. So to remove 1, we will replace it with 1 minus 1 plus 2 sine square theta, theta is pi by 11. What does that mean? So that means when we put z is equal to 1 in this relation here, in this form or in this form, when we put z is equal to 1, what does that mean? That means we are heading towards the series of product of sine terms. Okay, so now 1 and 1 gets cancelled. So see, the first bracket itself gives us 2 square into sine square of pi by 11 bachcho. Now if we move to the second bracket, see, alpha square, in second bracket it was z minus alpha square. Alpha square will be, if alpha is cos 2 pi by 11 plus iota times sine 2 pi by 11, alpha square will be cos 4 pi by 11 plus iota times sine 4 pi by 11, isn't that? Now when you apply it, so here what you will get cos of 4 pi by 11, and then applying the formula you will get here. So the second one again be 2 square into sine square of 2 pi by 11. Similarly 2 square sine square of 3 pi by 11, 4 pi by 11 and 5 pi by 11. Okay, so how many times we have 2 square? We have 5 times 2 square. So therefore 11 is equal to 2 raised to the power 10 into sine, rather I will write it in this form. I believe all of you will understand it now. So product of k goes from 1 to 5, sine square of k pi by 11, isn't that? So now bring it this side. So what is it? So it's like 11. So product of sine square of k pi by 11, k goes from 1 to 5. This is nothing but 11 raised to the upon 2 raised to power 10. So therefore, what's our answer? So therefore, the series, the value of the series which we need here is not a square. So you will take a square root both the side. Okay, and this is nothing but root 11 by 2 raised to the power 5, and that's the answer. Okay, so that's coincidentally, see, that was not deliberate, as I said. Actually I never remember which one will give the which one. Okay, z is equal to 1 will give cos series or sine series. Okay, so that was a coincidence that I put z is equal to 1 and I got the first part. So similarly now you put z is equal to minus 1 here. So put z is equal to minus 1. See what's the difference it will make. First thing, when you put it in LHS, there are 11 terms. Okay, so 1, then minus 1, plus 1, minus 1, plus 1, everything will get cancelled. So you will be left with 1 in LHS. In RHS, when you put z is equal to -1, so here it's 1, square is 1, but it will give you plus times 2 times real part of alpha. So here it will be 2 plus 2 times real part of alpha, which is cos 2 pi by 11. What difference will it make? So take 2 common, so you get 1 plus cos 2 theta, which you will write it as 2 cos square theta minus 1. So you got 2 square into cos square of pi by 11 in the first bracket. Similarly 2 square into cos square of 2 pi by 11 in the second bracket. So that will generate the series of cos here, the product of cos term. So therefore it's 1 upon 2 raised power 10. So therefore the product of series of cos, where it is k pi by 11, k goes from 1 to 5, will be 1 upon 2 raised to the power 5. So that was the purpose behind sharing this question here, bacho, so that I can just share with you how to solve such series. Which series? See, if you have odd denominator, you have a product of sine series or cos series, and within the sine series or cos series, within like in the angle, the denominator is an odd number, and then in the the variable of the series takes 1 less than half the values, like 1 to 5. If there would have been like 21, then k would have gone from 1 to 10. If this would have been like 31, k would have gone from 1 to 15. So in any such case, you can solve, or you can use these following steps, the following method, to get the value of the series, bachcho. So that's the solution for today's question, bachcho.